In this video, we'll take a look at section 1.4, which is on inequalities and interval notation. Now, our first objective is to determine whether a given number is a solution of an inequality. An inequality is a sentence containing one of these symbols. We have an arrow pointing to the left, an arrow pointing to the right, an arrow pointing to the left with a line underneath it, an arrow pointing to the right with a line underneath it, or the not equal to symbol. Let's go over what each one of these are. So the arrow pointing to the left is a less than symbol. And then if it has a line underneath it, this is less than or equal to. And then if the arrow is pointing to the right, we have greater than. If the line's underneath it, we have greater than or equal to. And then the equal sign with a slash going through it is not equals. Let's take a look at an example. Determine if the number is a solution to the inequality. So just like what we saw with equations, if you want to check to see if it's a solution to the inequality, what we're going to do is plug it in we're going to plug in the value for our variable. So in this case, we're going to plug in our 8 for our x. So we have 3 minus 8. We want to see if this is less than 2. We want to see if this is a true statement. Let's go ahead and simplify. So 3 minus 8, that gives us negative 5. We have negative 5 is less than 2, which is a true statement, which means that 8 is a solution. 8 is a solution. Let's take a look at another one. This time we want to see if 5 is a solution to this inequality. So let's begin by plugging in our value. So we have 3 times 5. Plus 2. We want to check to see if this is less than or equal to 4 times 5 minus 3. We want to see if this is true. Okay, so let's go ahead and simplify. We get 15 plus 2 less than or equal to 20 minus 3. So it's 15 plus 2, we have 17, and we have less than or equal to 17. So we want to see if this is a true statement. So that symbol that we have is less than or equal to. Now we know that 17 is not less than 17, but it is equal to it. So it has to satisfy one of those conditions. It has to either be less than it or equal to it, which in our case it's equal. So that means that it is a solution. So 5 is a solution. So that was objective A. We wanted to check to see if a numerical value was a solution to our inequality. Now our next objective, we're going to be solving and graphing inequalities. And we're also going to take a look at writing the solution set in interval notation. So if we have the inequality symbol less than or greater than, when we're writing out our solution in interval notation and also with graphing, you're going to be using parentheses. If you have the symbol less than or equal to or greater than or equal to, you're going to be using brackets for your solution and for your graphing. Whenever you have the infinity symbol, you're always going to put a parenthesis next to that. So always put parentheses next to infinity. Now the strategy for solving inequalities, it's the same strategy as solving equations, what we saw in section 1.1. Only difference here is whenever you multiply or divide by a negative number, you must flip the inequality symbol. You have to flip that sign. Let's take a look at an example. So solve and graph the inequality, write the solution in interval notation. So we have x plus 4 is less than or equal to 7. So in order for me to solve this inequality, I want to get my x completely by itself. So this 4, I have to move to the other side. So let's go ahead and subtract 4 from both sides. We get x is less than or equal to 3. Once you have your variable completely by itself, your variable is solved. Now what we have to do is graph it, and then we want to write our solution in interval notation. So let's draw our number line. Say the middle of it is 0, and let's say 3 is over here. Okay. So we have x is less than or equal to 3. So since we have the symbol less than or equal to, that indicates we have a bracket. Now what we have to do is determine what side we're going to shade in. So we want everything that's less than or equal to 3, which would be everything to the left of it. So we're going to put a bracket facing to the left and shade in the left-hand side. So now we have our graph, and now we have to write this in interval notation. Whenever you're writing your solution in interval notation, you always want to go from left to right, from smallest to largest. So notice how our arrow keeps going on forever in the left direction. So this is indicating it's going all the way to negative infinity. Since I have an infinity symbol, I have to put a parenthesis next to that. And this goes all the way to 3, and we have a bracket. That bracket means it includes that number 3. So 3 is part of the solution. So our interval notation would be from negative infinity to positive 3. Let's take a look at another one over here. So same type of problem. This time we have 2x minus 3 is greater than or equal to 3x minus 1. So let's begin by solving for x. We want to get x's on one side. So let's go ahead and subtract 2x from both sides. And now this positive 1, I want to move it to the other side. So I want my constants on the left and I want my variable on the right. So now on the left-hand side, we're left with negative 3 plus 1, which gives me negative 2. And then I have greater than or equal to 3x minus 2x, I get x. Okay. So I have my variable completely by itself. Okay. So technically this inequality is solved for. But now I have to graph it. Okay, so here's my number line. Let's say 0 is over here. Let's put negative 2 on the left-hand side of 0. First, determine if it's going to be a parenthesis or a bracket. So since it's greater than or equal to, I have that equal to symbol. That indicates it's going to be a bracket. And now there's a misconception where students believe wherever the arrow is pointing, that's where you're going to shade, which is not true. Always read it with your variable going first. So if I read it with the other direction, this is telling me that x has to be less than or equal to negative 2. So less than or equal to negative 2, that's telling me I have to shade to the left. And then in interval notation, so that arrow is going to keep going to the left. So we have from negative infinity to negative 2, and our 2 gets a bracket. Next example, we have negative 2y is greater than 10. So I want to go ahead and solve for y. So in this case, I'm going to have to divide by negative 2, which now gives me y is, now be careful in this situation, since I divided by a negative, I have to flip that inequality sign. So now I have y is less than negative 5. Let me go ahead and graph. So here's 0. Let's say negative 5 is right over here. Now, since I have the less than symbol, I don't have less than or equal to. That means I have a parenthesis. I'm going to have a parenthesis, and then everything less than negative 5 is everything to the left of it. Now let's go ahead and write our solution interval notation. We have from negative infinity to negative 5. This time we have a parenthesis next to our value, our number. Next one, a little bit more difficult. So let me go ahead and rewrite it. So we have 17 minus 5 times y minus 2 less than or equal to 45y plus 8 times 2y minus 3 minus 39y. So remember, we have the same strategy as if we were solving equations. So if this were an equation, I would want to get rid of the parentheses first. So I'm going to go ahead and distribute out this negative 5. Then I'm going to go ahead and distribute out this 8. So I have 17 minus 5y plus 10 is less than or equal to 45y plus 16y minus 24 minus 39y. Now I go ahead and combine like terms. So I have negative 5y and then the 17 and 10 gives me 27. Less than or equal to, let's combine all these y's with each other. So the 45y and the 16y gives me 61. 61y, and now 61y minus 39y, I get 22y. So I have 22y minus 24. Now we want to go ahead and move y's to one side and move the constants to the other side. So I'm going to go ahead and move my y's to the right hand side. And I'm going to move my constants to the left. Okay, so I have 27 plus 24, that gives me 51. I have less than or equal to. Now 22y and 5y gives me 27y. Okay. Now let's go ahead and continue to solve for y. We'll go ahead and divide both sides by 27. So 51 over 27, here let's write out our solution over here first. So we have 51 over 27 is less than or equal to y. And now check to see if you could simplify the fraction. Now one other thing I want to do is I want my y to be on the other side so I don't get confused with graphing it. So I have y is greater than or equal to. And now we have to determine a number that goes into both 51 and 27, which is, use 3. 3 goes into 51 17 times. It goes into 27 9 times. So we have y is greater than or equal to 17 ninths. So let's go ahead and graph it. So let's say this is 0, and then 17 over 9. Let's approximate it as over here. So this would be a number in between 1 and 2. And now greater than or equal to, so we have a bracket, and we have to shade in to the right. And lastly, we have to put in interval notation. So we have 17 over 9, comma, infinity. Okay. Now, one last objective in this section. Applications and problem solving, so word problems. Now we have some keywords here which indicate what type of symbol that we will be using. If you have the keyword is at least, the translation for that, the symbol that you're going to be using is greater than or equal to. If you have is at most, that indicates that you have a less than or equal to. Cannot exceed also means less than or equal to. Must exceed means greater than or equal to. If you have no more than, that means less than or equal to. No less than means greater than or equal to. Let's take a look at an example. So, as a result of the increase in online activity, the employment demand for web developers is expected to increase 27% from 2014 to 2024. The equation P equal to 3,950T plus 148,500 can be used to estimate the number of web developers in the workforce, where T is the number of years after 2014. So T is the number of years after 2014. Determine the number of years for which the number of web developers is greater than 175,000. So we have to determine when is the number of web developers going to be greater than 175,000. Well, first, we have an equation that helps us estimate the number of web developers. So let's go ahead and write out that equation. So we have 3,950T plus 148,500. And now our keyword here that indicates which inequality we're going to be using, we're trying to figure out the number of years for when the number of web developers is greater than. So we're going to put greater than 175,000. And now we go ahead and solve this inequality. So let's solve for T. We're going to subtract 148,500 from both sides. Okay, so now we end up with 3,950t is greater than, and let's go ahead and subtract. Okay, so we have the 175,000 minus 148,500. That gives us 26,500. And now let's go ahead and divide to get t completely by itself. So yeah, t has to be greater than. Let's go ahead and round it. It has to be greater than 6.7. So the number of years it's going to take for the web developers to be greater than 175,000 is t would have to be greater than 6.7 years. So 6.7 years and beyond, the number of web developers will be greater than 175,000. So that was it for this section. Just remember, if you have any questions, do not hesitate to email me and I will answer pretty quickly.